Let's start by taking a look at what we did yesterday. Just to remind everybody about this, that we have these different values within our equations. The number in front was called the amplitude, right? And that was the vertical stretch. Right? That was the vertical stretch. And then we had this other value of b, which was how many times you actually cycle through every 2 pi. So it could be half the graph, the whole graph, 2 graphs, right? So something like this, when it has a 2x, that means you're going to go through the whole cycle of cosine 2 times by the time you get to 2 pi. Right? Now, I told you to skip part C yesterday just because these are kind of related. They're very closely related. So you can look at them in 2 ways. Unfortunately, when you try to do both of them at the same time, it could be confusing of like, wait a minute, like, so does that mean this, or is that right? Because I think I got it, but if you just do one for one night and kind of get it down and then learn about the other one the next day, it's a little less confusing. So it's 2 ways of looking at the same thing. This one just says for any graph, you can see like on this one that we did yesterday, it just means this value 2 just means by the time we get to 2 pi, I'm going to go through the cosine graph twice, which means I have to get through the first one by the time I get to pi, and then repeat cosine again, and I'll get to 2 pi. So I'll have 2 cosine graphs by the time I get to 2 pi. Another way of looking at it is doing this, which is called the period, which is you just take 2 pi and you divide it by this b value. Okay? So of course 2 pi divided by pi, this is just telling you every pi the graph repeats. So it's kind of like the same thing but different. But I don't want you to get too bogged down on what they mean. I want you to probably pick one that makes more sense and just go with it, right? Now there's questions that ask you like what is the period of this particular graph, so you have to know this. But as far as when you're graphing, it's usually easier to think about it one way or another and not trying to do it both ways. So just know these are very similar to each other. So today all we're going to do is add in one more thing, which is called the phase shift. So we're going to add in one new number right here. But before we do that, just review like you guys just did. We know our sine in general, when you're graphing it, starts at 0. Cosine starts at the maximum. In this case, it would be positive 1. That's the main difference between those, right? They both cycle through after 2 pi. Okay? And the best way to do this is to start at 2 pi and go halfway, right? And then you get pi. And then go halfway between those, right? And you get pi over 2. Halfway between here, get 3 pi over 2, right? So that's the best way to go about this when you're doing these graphs, so that these are evenly spaced. Go from 2 pi, take half of that, take half of that, take half of that, so they're all in the right place. And you could do that for both of them. All right? So just good to know in general how things work. So that's the max, that's the 0, that's the min, just goes up, that comes back down, and this is basically the unit circle. All right, it's basically just the unit circle. One for the y values, one for the x values. And you guys just did this, so you saw that the amplitude was 4, and you could put 4 right here if you wanted. Make that 4 and make this negative 4. Right? It might look different from somebody else that put 4 up here and 4 down here. So it's not necessarily wrong if as long as you're consistent. Right? The number of cycles over 2 pi, that's what this value is. Right? So you should have 1/2. Which means I'm going to get half of the cosine graph, which means from here to here. I'm going to get half of the graph by the time I get to 2 pi. Right? So that means it should look something like this. Is that correct? Oh, it's 1/4. Sorry. Woo! Try that again. 1/4. 1/4. So I need to get through 1/4 of the graph. So that's that first 1/4 of the graph right here. Yeah. So we should be going, yeah, like that. something like that. Just that from starting at the top of the amplitude, right, which is 4, going all the way to the bottom. Right? So if you had your 4 up here, it definitely looks like this. If you had your 4 where mine is right here, it might look like this. They're both correct. It's just one, you know, just depend on how you do your scale. Okay, so just keep that in mind. Sometimes you can look up here to have different answers, but they can all be correct. That's totally okay. Now you can look at this as the period, which is 2 pi divided by 1/4. And sometimes the division of fractions throw people off. So basically this asking, quarter is kind of a nice, because you guys know money, you know, how many quarters go into $2? 8. So that's why 2 divided by 1/4 equals 8. Which means that I need to have stretch my graph out to get the whole cosine graph. I need to have 8 pi, because 2 pi only has this fourth of it. So I need 3 more of these to stretch out to get the whole cycle of cosine. And we looked at this a little bit yesterday, then we threw in a negative, just so you know, if I have sine of negative x, that's the same thing as negative sine of x. That was one of those identities from the very beginning that we discovered. So just like any other graph, it does the same thing, right? Meaning if I go to my Desmos, Desmos. Yeah, if I go to Desmos here, and I did this with our old friend the parabola, said y equals x squared, and I get a parabola, and then I go ahead and put a negative in the front. All that did was flip the graph, right? So it does the same thing with sine and cosine. So if I have y equals sine of x, I get this. If I put a negative in front, it just inverts or switches the x's. I mean, switches the positive y's and the negative y's, right? So in effect, right, just flips the graph over. All the positive ones become negative ones. All the negative ones become positive ones. You'll notice that the zeros don't move. So you'll see right here, I zoom in, at 0 here and right here at pi, those don't move because the opposite of 0 is just 0. So it's just the positive ones and the negative ones that are switching places. Right? So we can graph anything, and we will have some, you know, shortly coming up that will have negatives in front. So that's why it's worth bringing up right now. So I know I'm going to have a whole cycle from here to here. Which means I'm going to be back halfway through. I'll be back to 0, and since it's negative, I'm going to go down first and then up. This is the same as if I went backwards. Starting at 0, I went to quadrant 4, got to negative pi. Now I'm in quadrant between 1 and 2, and now I'm back to 0. So it's like going backwards or reverse around that unit circle. All right. So we looked at this already and we said, well, what if we throw in another number and we start, you know, it does the same thing as every other graph we've ever worked with. So let me pull up my Desmos real fast. A little reminder, if I had this, let's see, I'll take off the negative and just have positives. A little reminder how things work here. If I did like a -2 to the second power, turn it on, right? You'll notice that it moves to +2. So the -2, you might think in, okay, the negative direction is the left, but it actually moved the graph to the right. And same thing here, if I make this +2, it actually moves to the left. So it's opposite of whatever this sign is. And I can make this, I'll put just C and put a slider there just to illustrate that the positive values do make it move to the right, left, right, to the negative territory. And I make this a negative number, it does move it to the right in positive territory. So the same thing is true. I just throw a sign in front. You can see when I make it more positive, it appears the graph moves left. If I make it negative, it appears the graph moves right. So, in other words, all your intuition about graphing has not changed. right? Everything is going to move exactly as you expect it to. Right? Don't change a thing. So just practice a few, and we'll get started on the homework pretty quick here, just so you can, have time to absorb it all today. Now you'll notice, since we have our scale is all with pi here, our phase shifts are going to have pi's in them. That's so that it matches here, because if we have this on our x-axis, all in terms of pi and radians, and this is just a regular number, that'd be kind of difficult, because we'd have to get decimals. Like instead of pi, we'd have to put 3.14, right, to actually graph things. So it's the one drawback about decimals, I believe, is that I don't know if you can make this into radians or not. Right? It stays 0, 1, 2, 3, 4, 5, and so on. There might be a setting somewhere that puts it into radians here, but it doesn't change the axes here. It stays regular old numbers. So just know, if you're using decimals to help yourself out, that the graphs might be a little hard to compare. So let's just go through all the normal steps. Don't change a thing. We'll just add in one extra step. So we got our amplitude, which is just 1, because the number in front here is, even though it's not there, it's implied to be a 1. And you can make this 1, you can make this -1. This much we already know. And there's no number in front of x, or no number written, so we assume it to be 1 as well. So that means we're going to get through a whole cycle of sine by time we get to 2 pi. Okay. And then we have our period, which is just going to be 2 pi divided by 1, which of course is 2 pi. Doesn't change. And the new thing is right here. So what you do is you just take this value right here and you actually set it equal to 0. Two ways of looking at it. I say x minus pi equals 0. And if I solve that for x, it means we're going to move this pi direction, or pi units, to the right. And on this graph, you can see pi is 4 squares. 1, 2, 3, 4. So you want to translate this and know what it means. That's 4 squares to the right. It might seem trivial to actually write that out, but it saves you from a lot of headache and a lot of mistakes. And like we've always done with apparent graphing, it's good to put the graph without the phase shift and then do the translation and then actually graph it. So let me show you. I'm going to ignore that there's a minus pi here and just do the normal sine of x. Right, so I'm going to start at 0, 0. I'm going to put x's here instead of dots. And I know I'm going to end here, which means halfway through I'm going to be back to 0. Since it's a positive 1, I'm going to go up first. And then the sign of 3 pi over 2 is -1. That's down here. Now I'm not going to actually graph this because that's not my real graph. What I'm going to do is, now move each of these 4 squares to the right. I actually wrote it out so I know exactly what to do. So each one of these I'm going to say, okay, this one 4 to the right starts here. This one 4 to the right, 1, 2, 3, 4 starts here. These are 4 to the right and they actually go off the graph. We can estimate them. This one's way over here. It's almost on this next one. And that's going to be our actual graph. It's the same thing, but the whole graph is moved over pi units. So in a sense, we're starting at pi instead of 0. But the graph otherwise looks identical from where we started. Okay. Let's just do one more, and then we'll practice a few in the homework and let you guys get started. So one more time, this has some more stuff going on, right? We don't have a 1 and 1 for A and B. So let's try this with a little bit more going on here. So on 5, we got an amplitude of 3. So right away, I use that to label my axes properly. We're going to cycle half of the cosine graph every 2 pi. So by the time I get to 2 pi, I'm going to have half a cosine graph, which is the same as saying in order to do a full cycle, I need 4 pi. So let's just graph those up to this point. So cosine, of course, starts high. Start here. Use my x's. Now I'm going to get through half of the graph by the time I get to 2 pi. So half the graph, remember the cosine graph, starts high, half the graph will be low. The other half would bring it back up, right? So that means I'm going to finish down here. Which means in the middle, I'll be at 0. Okay. So if this, without the phase shift, you don't have to dot this in, but this is what it kind of looked like. But we have this phase shift. Now there's a little thing going on because we have a 1/2 and a pi over 2. Like we did before over here, I'm going to take the whole thing, set it equal to 0. Everything in the parentheses. It's a little bit more solving. So we got 1/2 x plus pi over 2 equals 0. So half of x equals negative pi over 2. We're going to double both sides, multiply both sides by 2. So we have x equals negative pi. All right? So it might look like you might get in the habit of just saying, well, whatever this is, it's the phase shift. That would be incorrect. It's whenever this thing equals 0. That's what the phase shift is. So we gotta move it. Everything negative pi, which means on this particular one, 4 squares to the left. Right? Because from 0 to pi is 4 squares. Each one of these I'm going to move, count them over. 1, 2, 3, 4. 1, 2, 3, 4. And over here, 1, 2, 3, 4. And that's my actual graph. And mind your shape. You're just learning the shapes of all these, but you know for sure this isn't a straight line. It should not appear to be straight, right? But sine and cosines are curves, right? So this should be curvy. So that's just a few examples from beginning to end. Do you guys want to do more of these together, or do you just want to start working on your own? How are you feeling? Just feel comfortable, or just maybe 1 or 2, or what say you? Since no one's jumping and joining for me to talk more, I'll let you guys start working, okay? And you can use Desmos to check, but before you do that, work with each other. Just do a few. Hey, did you get this? Okay, I got that. Okay, I think I'm doing this right. You're learning little by little, so don't rush through it. Check as you go just to make sure accuracy is on point. All right, and I'll be around if you need help too.